Radical. That's your title. Now, before I get into simplifying radicals, let me go over something about mathematics that you know since junior high. Okay, you don't have to write this down. There's some protocols in math. When I say protocols, those are like expected behaviors and expected ways to write certain things. In other words, for instance, let's say you're doing a math problem and in the end you get 2/4 as your final answer. Now you know and I know, you've been trained since you've been a little kid that whenever you have a fraction, it's kind of bad manners to leave a fraction unsimplified. That's a protocol. It's expected behavior that you're supposed to perform because these are just conventions and it's just like good manners. If your protocols would be like you're at a fancy dinner, you don't burp at the table or fart at the table, right? Those are expected protocols that you're supposed to follow. You address the people who are older than you as sir or ma'am, right? Even people who are your age, sir or ma'am. If you're a child and you're addressing an adult, you say Mr. by their last name, and Miss or Mrs. Those are protocols. Well, in the same way, there's protocols in mathematics. For instance, 2/4 should become 1/2. You don't leave your answer this way, even though it's technically not wrong. You have to simplify. Okay? So what I'm going to cover today, this title, Simplifying Radicals, is a protocol. It's kind of like good manners. And here's what I'm talking about. Example 1. Well, before we get to example 1, go and write the word perfect squares on your notes. It's an easy lesson today. Perfect squares. Now, those who've had math 2 with me, you will remember the word perfect squares. And let me list them. When I say perfect squares, what I mean are numbers like this: the square root of 4, the square root of 9, the square root of 16, 25. Go write this down for me. 36. What's the next one after 36? 49. So why are these numbers called perfect squares? Well, because if you take the square root of these numbers, they become nice whole numbers. Look at it. Go and write these down. Right? Go and put these down on your notes. Next one up would be 64. 81, huh? 121. Let's go up to 12. And 144. It's an infinite list, correct? But what I mean by perfect squares is this list here, these numbers, 4 and 9, 16, and so on. Now you need to know what perfect squares are for what I'm about to teach you. Now, here's the good manners, bad manners aspect of my lesson now. Suppose we're doing a math, let's say we're finding the roots of a function. And in the end, we get x equals, this is example 1, ready? Let's say we get x equals the square root of 20 as our final solution. All right, x equals square root of 20. Now, if I get my calculator out, which let me do right now, square root of 20, is that a perfect square or not? No. It is not. Let me just prove it for those of you who are doubting me. I have my calculator up. Let me hit the square root of 20. Look at when I hit equals. Look what happens. I have an infinite non-repeating decimal. We call this an irrational number. So square root of 20 is not a perfect square. Okay? But even though it's not a perfect square, we just don't leave our answer this way, our solution. We have to simplify the square root of 20. And that's the title of our notes, Simplifying Radicals. When I say the word radical, that's just a synonym, a word that means the same meaning. Radical and square root mean the same thing. So if I say, let's simplify the square root of 20, here's how we do it. Ready? We're going to break it down into two factors. A square root times another square root. I'm going to write that down. But here's what we got to do. I'm going to put a star next to it. We got to make sure, this is the key step here, make sure one of the factors is a perfect square. That's all you got to remember. And the rest is gravy, easy, cakewalk. What are factors of 20, but one of them being a perfect square? 4, right? 4 is a perfect square, and it's also a factor of 20. Square root of 4 times the square root of 5 is the square root of 20 if you multiply them. Right? Notice how I took 20, I broke it down in two factors. I made sure one of the factors was a perfect square. 5 is not a perfect square, but 4 is. See, they're both factors of 20, but only one of them is a perfect square. So look at my final simplified version of square root of 20. Right, square root of 4 becomes 2, so my final answer is 2 times the square root of 5. This is my simplified version of square root of 20. You see. This is the good manners right here. You leave your solution as 2 square root of 5, not square root of 20. We simplified square root of 20 to be 2 square root of 5. What you need to know in your mind as Math 3 students, 2 times the square root of 5 is the exact same value as the square root of 20. Let me prove it. Look at my calculator. I still have the square root of 20 on my screen. It's right there. Let me erase that and hit 2 times the square root of 5 and see if I get the same number. Watch this. 2 times square root of 5. I'm still going to get the same number as the square root of 20. Watch. There it is. 4.47, blah, blah, blah. That's what the same value I got when I hit square root of 20. So, back over here. 2 square root of 5 is exactly the same value as the square root of 20. It's right up there. This is the same thing. This is just a simplified version of square root of 20. Try another one. Example 2. Let's simplify. Here we go. Let's simplify the square root of 75. The square root of 75 is simplified. Now, before I even simplify it, I have to ask myself, is the square root of 75 a perfect square? Is there such a number that multiplied by itself becomes 25? It's not, so let's break it down now. Here we go. Let's break it down. Square root times the square root. Now remember what I have to remember in example 1. I have to make sure, between the factors I pick, I got to make sure one of the factors is a perfect square. So from my list here, look at this list. Which ones are factors of 75 and making sure one of them is a perfect square? 25, huh? Look at 25 right here is a factor of 75. So that's one of the factors I'm going to pick. Watch this. Square root of 25 times the square root of 3 becomes the square root of 75. Notice how one of the factors is a perfect square. 3 is not a perfect square, but 25 is. So that becomes 5 rad 3. We're done. So we simplify the square root of 75 to become 5 rad 3. It's easy. Once you get the hang of it, it's easy. Today's lesson is very easy today. I figured it's Monday, I want to go easy today. Try example 3. Oh yeah, Tuesday. You want some more coffee? You're right. You want to stand? Oh, here we go. Something's again. Here we go. Rad, let's try 48. Square root of 48. This one I want to try, I'm going to show you 3 different ways of doing this one. So, let's do it. Is square root of 48 a perfect square? No. So now we got to break it down. We can't just leave it that way. bad manners. So rad what times rad what? Here we go. I love it. 16 fits into 48 3 times. Beautiful. Square root of 16 is a perfect square, so we get 4 rad 3. Beautiful. Let me do it again. Option B. That was option A, the way Flotus just said. Let's try a different route. Square root of 12 and what? There you go. So look at 4 is a perfect square, but 12 is not. Watch this now. So by the way, we finished, but I'm going to show you I'm going to do it again in a different manner. I'm going to use the factors that Mr. Quonset just said. Square root of 4 is 2, so it's 2 rad 12, yeah? But I'm not done yet. Rad 12 I can keep breaking down. Watch this. What's a perfect square factor of 12? 6 not perfect square. 4 is, huh? Watch this. 4 times rad 3. Look at that. Watch this. What's the square root of 4? So 2 rad 3, but this 2 comes down to my final answer. Look at what we got. 2 times 2, I can multiply this normal number times normal number, so I got 4 rad 3. Okay, same thing as we got the way Lotus taught us. Okay. I think there's still another way, if I'm not mistaken. Let's see. 9, 4, 16 we got. Yeah, that's it, actually. Okay. All right. Very good.